So thanks for having me, CDA. Really appreciate it, and thanks everybody for being here. What I'm going to talk a little bit more in detail about is specifically how to use some of these techniques that James has talked about, um, particularly for condition assessments of dams and in particular concrete structures and appurtenant structures.
So I think your
Um,
camera's off.
okay, let's see if I can fix that. Is that working okay?
Uh, no, but now we've lost your screen. So maybe just worry about your presentation and we'll,
I guess my camera was off for too long. Sorry about that. You'll just have to look at me presenting from a black screen, I guess. Sorry about that. So we'll be focusing mainly talking about photogrammetry and some of these other multi payloads that James mentioned, particularly thermal and that proprietary acoustic sensor that taps the concrete. This particular case study is going to focus on a chute spillway, but just keep in mind the details that are going to be described here are mostly applicable to any type of concrete structure. Um, what we're going to talk about a little bit is just a little bit about our company and a little bit of an overview there. Talk particularly about the project and the client that we worked with for this particular case study, how the data is used. I think one of the biggest important things is making sure that we've got a good use out of the data that we're collecting, how we processed it, some of the challenges that we encountered and some of the limitations, and then ultimately just a high level on some of the other use cases for condition assessments in particular. So just a quick one on us, 50 plus team members located in Victoria, British Columbia, Canada. We specialize in the hydro sector. I've done a number of projects around the world. Um, Ultimately, the project here is a structure located in Arizona. Um, probably under a typical condition assessment, it's probably about a seven-figure condition assessment or a high six-figure condition assessment. It's in a quite rural area. The design of the geography makes it very difficult to get specialty vehicles in the area to do assessments and to lower teams down to do the inspections. So it's quite a challenging process. And ultimately, those are some of the challenges they faced at the site. So some of the goals of working with them was to avoid some of those risks and obviously those costs of putting personnel on site. And ultimately, I think more importantly, create a baseline data set of the condition that could be tracked through time and periodically monitored to see how things are changing. Um, Again, this is going to focus on photogrammetry data, very high resolution, about zero point zero 0.04 inches per pixel or about a millimeter per pixel resolution. So that means every single pixel represents that size in the real world. There's a couple different ways that this data can be used that I'm going to show you today. Primarily five key ones that we hear from the clients that we work with. The first one's actually in construction. So a lot of times when we're constructing a new dam, doesn't happen too often, or a new spillway. Um, we need to get kind of a final construction record, right, when that asset's completed in terms of the condition. So what we can do is use some of this technology to track that, document it, and then use that as our baseline for the condition going forward. That way, 5, 10 years down the line, maybe we've got a new dam safety staff in place. We can start to look back and see what that original condition was on project delivery to the client or on final construction, and understand how it's changed and maybe how it hasn't changed, and more importantly over time. Um, Generally, just asset management, so understanding just general deterioration rates and percentages over time and which assets are deteriorating fastest in the portfolio. If we're going in for a major maintenance design or major repair works, we can actually use some of this technology to understand what the scope and scale of that repair is going to look like. So how much material do we need for crack sealant across all the cracks that are of concern to me? Um, A couple more as well is actually documenting how the maintenance contractor performs. So if that's an internal team or an external team, actually tracking, who did that maintenance. We've heard a lot from our clients that we work with, that a lot of times certain contractors can perform better than others. So being able to document that and then 5 years down the line, refer to the performance of that maintenance and influence our decision making. And then the final one is actually documenting the performance of the repair material, right? There's always new materials being used, innovative types of um, methodologies. So being able to document that and understand those processes that were used and how things worked out well or didn't work out well. And ultimately, this is in the goal here is to operate and maintain that structure over time and spend less on maintenance dollars by ultimately keeping a um, higher quality asset or an asset that's in better condition, and not doing some more preventative maintenance than reactive maintenance. So to give you an idea of how we typically work, we collect very high resolution imagery data, so that photogrammetry data that James was talking about. Um, we'll collect about, drone will fly autonomously. We'll fly about 8 meters away from the structure, so extremely high resolution imagery is being collected. It's not that easy. We've got power lines, we've got electromagnetic interference issues that are in these situations, um, all types of things that might impact our operation. We've also got a rover based system. So, rover can actually go up, and what that's actually doing is physically tapping the surface and mapping any of that delamination, much like you or I going out there on the structure and tapping it with a hammer to identify any delamination. We're going to be doing the same thing on a chute spillway or either on a vertical structure or even an inverted structure. Um, for this particular case study, as I mentioned, some of the key challenges that we faced, electromagnetic interference was actually causing issues to connect to the GPS, which affects the positioning of the device. Because of the spillway, actually the grade on it, we actually invented a unique cart solution to collect data points on this structure. Um, and because of some of the power line obstructions, we had to adjust the quality of the camera we use to actually capture from a farther distance. So depending on the camera you use, the lens, all that detail can impact how far you need to fly from the structure in order to capture that 1 millimeter pixel resolution. It was brought up a little bit earlier, but also high winds are an issue. So it's something we did expect experience on this site was high winds, and so that did result in some camera stability impact. So we had to do some post processing work to de-blur some of those images, and we also had to recapture imagery at certain parts. So it's something that is a process that continually has to be um, refined, and you have to have the right people in the field to make sure that they understand the proper quality control processes. But what we're able to get is a high level of detail like you're seeing here. So what we did is, we used Bentley Systems, iTwin Capture, Reality Capture. They keep changing the name, but one of those. So we did an overall 3D model, which is what you're seeing in the top left, and then a much higher resolution model, which you're seeing in the bottom right. And so you're able to see each individual defect on the structure. Now, of course, not all the defects are important, but what we are able to do is go into, we bring all this into a cloud-based platform that we've developed, and each crack is able to be mapped out autonomously. So we have an algorithm that's developed to map out defects such as cracks, falls, efflorescence, and things of that nature. And what we're able to do is quantify based on the number of pixels that make up that crack, the length, width, and surface area of each defect. There's all sorts of unique capabilities of having all of this data in a web-based platform. We don't have to worry about data storage on local computers. We don't have to worry about um, computer speeds and computer storage capacity because it's all based on a web-based server. that does a lot of that processing for us. So each crack is quantified. Obviously, we understand that each defect isn't important, and so what having that in a web-based format allows us to manipulate the data. We can flag certain defects, set certain priorities, analyze the various defects in a useful way. And so all of these are mapped out, and of course, all the spalls are mapped out and quantified for us as well. So here's what that looks like on a project. Typically for a spillway structure like this, we can actually organize the structure in 2D, much like we would do, um, if we were drafting up some drawings for a rehabilitation. We bring everything in the 2D environment. We've got the delamination information along the joints of the spillway structure. We've got the spalling information, the cracking information, all in that two-dimensional environment. Um, we can zoom in, navigate, and this is a collaborative tool, right? We can have the contractors, consultants, asset owner on the same source of truth here, making comments, designing their repair plan, or tracking their asset performance over time. A lot of our clients that we work with, they like this type of technique. It allows them to go move towards quantities contracts. Um, so instead of issuing our conventional contract, now that we have actual quantities for how much material we need, we can issue quantities contracts when we go out for rehabilitation. So that tightens up that process a little bit more when we go out for tender. And we have a little bit more specificity and scope, when we're doing a massive rehabilitation, which is oftentimes a frustration in the civil engineering industry. One of the things that I get most excited about is the ability to track this over time. So we've been fortunate; we've had a couple opportunities with several of our clients to track changes over time autonomously. So this means tracking poor maintenance performance, which you can see here, track crack sealant and how that's performing year over year, um, automatically. So if we've done multiple surveys, we can work with some existing photogrammetry data sets. So if you already have a 3D model of your structure or imagery data of your structure, it's possible in a lot of cases to process that and then collect a new data set and see how those things compare. But a lot of it is dependent on what resolution that you've collected that data at, and what's the quality of your new scan that you're completing. Um, so this is a great example of a defect where back in 2020, it was just a minor crack perpendicular to the joint. 3 years later, we see that perpendicular crack has basically deteriorated um, into a spall. So all this information can be used and aggregated for us. Um, it automatically lets us know how fast our structure is deteriorating, both kind of on a 50,000-foot level, right? Where is which assets of mine are deteriorating the fastest, and more on a granular level, you can zoom in and see where you need to prioritize your attention on specific assets. And so you can see where that crack sealant's been applied and where it's working effectively and where it's not. This particular asset owner, what their plan is, they actually plan the asset they own is owned by the Bureau of Reclamation in the United States. They're on a 6-year review cycle, comprehensive review cycle. It's similar to like a 5-year dam safety review that we do in Canada. Um, what they plan to do is implement this technology every 6 years ahead of the CR, so ahead of the comprehensive review. And what that will help them do is they'll have that data when it comes to the comprehensive review to help inform some of their decision making, right? So if we've got the baseline scan and we have the repeat scan again ahead of the next CR, now that consultant or that internal team that's doing that review can analyze the data and then make a recommendation on whether any sort of further investigations needed based on that visual data set and the delamination data set that's been acquired over the years. Just some additional considerations here. Some really important things that our clients really focus on. Data security is highly important. having the data stored in a particular way that's preserved through time is also very important for us. We store all of our data on Amazon Web Services servers in the cloud. These are all U.S. federal government approved through the FedRAMP program, and we store it all locally in the country where the data is collected. So if the data is collected in Canada, we store it on AWS servers in Canada. If it's collected in the U.S., it's collected, it's stored in the U.S., et cetera, et cetera. The good news about this data set is because it's all in 2D, these files can also be brought into the CAD environment. So, for example, um, we're working on several projects right now where the client needs to go out to tender for a major rehabilitation. Um, and so what we're doing is helping clients move their data, these 2D defect maps, which are just basic TIFF files, into the DWG model space for their in the CAD environment. And so those can then be brought into the tender documents and put out for bid. One thing that's also really important, obviously, is that data longevity. So luckily, the CAD format is pretty standard these days. So if those condition assessment layers need to be brought into CAD, that also helps not only the security component but also the longevity component. Um, Again, data size and management is often a question because we're collecting at such a high level of resolution, oftentimes thousands of images in some cases, depending on the size of the asset. Obviously, data size becomes a particularly pertinent topic. But again, these files are delivered all over the web-based platform. So the good news is that data size doesn't become a huge deal for our clients unless they choose to store it locally on their own servers or hard drives, and which can be done. But again, the data can be brought into the CAD environment if it needs to be, draped over that, and that file is obviously a lot smaller. Couple other considerations: I wouldn't collect data just to collect data, so don't collect some of this condition assessment data just for fun. I would do it with a specific plan in place, right? If you've got an asset that's under construction, use it to baseline that new asset. If you have an asset that's coming up for some sort of rehabilitation, do it to get your accurate quantities on your rehabilitation, or tie this somehow into an asset management program if you have some high risk assets that are more concerning than others. On the same token, if there is no plan, I wouldn't sit around and do nothing. A lot of this technologies ripe for implementation, and a lot of the sometimes a lot of times we can sit around and develop policies and procedures without kind of fully understanding the technology. So sometimes it's very useful to implement technology, understand how it's working with your workflow, and then being able to work from that information. Data accuracy is also extremely important. James mentioned on-site monuments and ground control. It's really important when you're building a high resolution photogrammetric model to do that. Generally speaking, as James mentioned, the limitation on the drones in terms of the global accuracy of the positional accuracy is the GPS. And so generally in the best case scenario, you're getting plus or minus 3 centimeters of positional accuracy. And so your photogrammetric models are going to be, impacted by that. From a relative accuracy perspective, Bentley quotes about plus or minus 3 times whatever resolution that you're collecting at. So since we're collecting at about 1 millimeter per pixel, the relative accuracy is about, plus or minus 3 millimeters in terms of the measurements that we take within the photogrammetric models. It's also really important if you are going to implement drones for your condition assessment program, make sure they collect ground truth data. So for us, that means going on, setting crack gauges with our clients, having independent verification as well. In our case, for our acoustic sounding hammer, being able to tap the structure with the drone and also measure it with the conventional sounding systems. Other things, is in-house expertise needed? It really depends on how your data is used. For a maintenance design, you can either use an independent consultant, or a lot of times, clients love to use their own drafters internally. If you're doing, asset management, a lot of time spent using the platform is useful to understand. Um, and again, I would say not all drone data or data is this data in general is the same. LiDAR and photogrammetry are very, very different use cases. I would use photogrammetry more for visual defect mapping, LiDAR kind of more for um, you know, um, geometries, right? And getting your accurate geometries of your structure, and maybe, depending on the accuracy, maybe some movement monitoring. Whereas photogrammetry, I would rather use, and it has a higher level of detail on being able to see some of those smaller cracks. Um, I would also say not all contractors are the same. Not all drone pilots are the same. There's a lot of there's a kind of a saying in the industry called like a weekend warrior, where kind of people go out and fly drones just for fun, and then kind of do the commercial side on the commercial flights on the side. Um, and so again, not all contractors can collect 1 millimeter per pixel resolution and develop these types of models that you're seeing here. And it's quite challenging to be able to process that many terabytes of data. So just keep that in mind when you're selecting contractors to do this type of work. Um, and just some additional use cases before I turn it over to everybody here. You're able to use this not only on rock, or sorry, on concrete dams, but you can also use them for rock fill structures for monitoring over time, earth and embankment dams to get a model of those, buttress dams, arch dams, um, run of river structures, for example, um, and even structures like penstocks that where access is challenging. And sometimes drones aren't always the right answer, right? So there's also opportunities if you're using some manned systems, or even just handheld cameras at a high resolution to collect this type of photogrammetry data. So depending on your particular asset, and the particular needs of the monitoring program, the data collection can be tailored around that. So with that, I'll open it up for some questions.
Maybe we can take one and then we'll get back to the presentations here. Um, can you measure the crack depth?
No, unless you have enough separation between the crack, you can do some yeah, you can monitor the depth, but if there's not enough separation in the crack, um, you you won't be able to see the depth of it.
Any comments on the calibration and validation?
Yeah, is there um, yeah, validation is really important, I would say. Whatever contractor you work with, make sure that they've set crack gauges on the structure. Make sure that they set survey control and on site and survey targets to tie in the data set and ground control points. Um, but yeah, and make sure that they if they have a sounding device, or use thermal data to map delamination on the structure, make sure it's validated. Um, as part of the project.
Okay. Uh, thank you, Josh. We'll get back into the case studies.